Hi, I'm Neeraj Murarka, CTO and co-founder of Bluzelle Networks, and today we're going to be demoing Bluzelle Database's Tendermint consensus algorithm and how it works. With me here is Richard Nistuk. On to you, Richard.
Thanks, Neeraj. For this demo, I've created a swarm of 4 nodes on AWS, and I've SSH'd into each of the servers here. So we'll start with C00. I will show you that I've created 4 validators, each with equal voting power. And we can see that each of our validators, one per node, has a voting power of 100.
And that means that they have equal stake in the proof of stake algorithm.
That is correct.
Okay.
I'm going to go over to the 4th node, which I've called C03.
Okay.
I'm going to do a create over there. I'm just going to grab this. And this is our CRUD create command.
Okay.
Using the Bluzelle client.
Mm-hmm.
And this is the account I'm using to create the command, or to create my key value pair.
Okay.
I've just called it validator. It also happens to be the validator for this node.
So it's just it's just simplicity. It could have been any account, really.
Yes, to do the create. Yeah.
Sure.
All right. So that is the client telling me what it's going to send to the blockchain. I like that, so I'll say yes, and give it the correct password. It has successfully sent it to the blockchain. I'm going to grab the hash. BLZ CLI. I'm going to make sure that everything is okay. Just like that. And since it uses up all of the screen, I'll just type less. I'll pipe it to less. And I'm looking for success equals true.
Okay.
I've created a value, a key value pair. Now I'm going to show you the incorrect way of removing a node from the swarm.
Okay.
I'll go over here. I've now SSH'd into our Curium01 server. And I'm going to look at the log, or I'm going to look at where I started the daemon. There it is. And I go Control-C.
So this is one of the 4 validators, and what you've done is you've turned off the node. It's not validating anymore. It's still expected as a validator.
This node is no longer validating. So let's go over to another node here and just rerun the validator set. The consensus algorithm thinks that it's still there. I have not removed it from the validator, from the set of validators.
Okay. Interesting. Yeah, and that's only, the node is down. It doesn't mean it's no longer a validator.
That's right.
Okay.
So let's go over here and let's update. Oops, sorry. Let's go back here and update.
Okay.
Whoops. Using the same UUID and the same key. And I'm going to say my new value.
Okay.
From validator. I like that. All right. We've successfully sent it.
Yep.
We can double check. Query, transaction, grab the hash, fire it in there. Remember that it takes up most of the screen. There we go. And I've got success equals true.
Okay.
It's on the blockchain now.
All right.
Now, so even though we've knocked out one of the validators, one of 4 of the validators, we still had 3 validators with a power of 300, a total power of 300 out of 400. The blockchain still works.
Yep. And that's because you still have your 75% of the validators voting, which is more than the minimum required, which is 66% for Tendermint's Byzantine fault-tolerant supermajority to be reached, right?
That's correct.
Okay.
So now I'm going to SSH into C02, Curium02.
Yep.
I'm going to have a look at where I started BLZD or BLZD. Whoops, there. There we go. There we go. And I'm going to shut down this daemon as well.
Okay.
All right. Okay, so these two daemons here, they've been shut down.
Yep.
Leaving C00 and C03.
Yes.
Right? Let's have a look one more time at the validator set. Of course, the validator set still has 4 validators. It doesn't, it doesn't tell us that those 2 have been shut down.
Okay.
Let's go back here and redo our update.
Okay.
We'll just change the value. Okay. Okay, so it thinks that the message has been sent correctly. Let's go ahead and query the transaction. Something went wrong. Let's have a look at the logs here. Okay, so the network has been stalled. And if I go over to C00, we see the network is still stalled.
Okay, so these are the 2 nodes that are still running, but their network's not creating any blocks because there's only 2 out of the 4 nodes, which is 50%, which is not enough for a supermajority.
That is correct. And so blockchain is stalled.
Okay.
All right, I'm going to go back to C01.
Mm-hmm.
And I'm just going to go BLZD start. I'm going to restart this node only.
Yep.
And look at that. He's catching up very quickly.
Yes.
All right.
That was the first node you took down.
That was the first node I took down.
So he caught up
and
with all the blocks.
While that node was down,
yep,
we did a transaction which went through.
Yep.
So this node now has to catch up.
Yep.
I am not going to turn this node back on.
Okay.
I'm going to go over here. I'm going to SSH back into C03. I'm going to update it again.
Okay. Now, did that previous update even go through?
Yes, actually, let's check that out. Let's do a read. Query crud read, and I'm going to grab that from there. And my underscore key. This is not a transaction, it's just a query. And there it is, my better value.
Oh, wow. So it actually, the transaction, even though it didn't get confirmed right away because the network had stalled, was enqueued and it eventually went through when the network came back. That's really great.
Right. And in fact, let's go back and rerun that transaction to see, redo this hash. There we go. And we have success equals true, where before we got an error.
Yeah, fantastic.
Okay, cool.
So, that's actually really interesting. So it sounds like, just to summarize, we ran the swarm, we took a node down, everything works. We took another node down, everything stopped. We tried to do a transaction, it didn't go through. You brought one node back, you got back your supermajority, and the transaction went through, and everyone's happy. So we can see how consensus works and how that supermajority is so critical.
Yes.
Well, that's great, Rich. I think it's a great demo, and I hope our viewers have enjoyed seeing this. It's really revealing.
All right.
Thanks very much.